All right, let's dive into something that honestly sounds like it's straight out of a science fiction novel. We're going to talk about a paint. Yeah, a paint that can make a surface colder than the air around it with zero electricity, even while it's sitting in the bright, blazing sun. Yeah, just take a second and really let that sink in. This isn't just a paint that's good at reflecting sunlight. It literally finds a loophole in the greenhouse effect, the very blanket warming our planet, and just shoots heat straight out into the cosmos. It's a wild idea, and the craziest part is, it actually works. Okay, so these three things together, they kind of break your brain, right? We all know that if you leave something out in the sun, it gets hot. That's just how things work. But this paint gets colder than the air around it, while it's in direct sunlight, and it does it all without being plugged into anything. So how on earth is that even possible? Well, to really get why this paint is such a huge deal, we need to back up a bit and talk about the problem it's trying to solve. And the villain in this story, ironically, is the one thing we all rely on to stay cool: the good old air conditioner. Here's the thing you have to remember about your AC unit: it doesn't actually destroy heat. It's more like a heat bouncer. It grabs all the thermal energy from inside your living room and just shoves it outside onto the street. So yeah, your apartment feels amazing, but you're actively making the city outside hotter. It's a phenomenon called the urban heat island effect. And believe it or not, it gets even worse. Those refrigerant chemicals inside the AC, often called HFCs, are unbelievably potent greenhouse gases. We're talking hundreds, sometimes thousands, of times more powerful at trapping heat than carbon dioxide. So just think about that for a second. We are using super pollutants to fight the effects of pollution. And that right there shows you the trap we're in. It is a vicious, self-perpetuating cycle. The hotter the world gets, the more we crank up the AC. And the more we crank up the AC, the hotter the world gets. We're basically in a thermal arms race against ourselves. To break out of this, we've got to stop just moving heat around and actually start getting rid of it. So what if physics itself had a loophole? A kind of secret escape hatch that lets heat just leave? Well, it turns out there is one. And it's been right there, floating above our heads this entire time. And this is the secret sauce: the atmospheric transparency window. Just picture our atmosphere as this big, thick blanket wrapped around the planet, trapping in heat. But this blanket isn't perfect. It has a small window in it, a very specific range of infrared light where the blanket is basically invisible. Heat at that exact frequency doesn't get trapped. And what's waiting on the other side of that window? Only the coldest thing imaginable: the near absolute zero of deep space. It's the ultimate heat sink. So if you can design a surface that radiates its heat at exactly the right frequency to pass through that window, poof, the heat is gone, beamed directly into the cosmos, never to return. Now, for the paint to pull off this incredible magic trick, it has to nail a two-step dance. First, it has to be a phenomenal mirror, reflecting almost all the sunlight that hits it, so it doesn't absorb that energy and heat up in the first place. But that's not enough. Second, it also has to be a super efficient radiator, actively pushing out its own heat through that very narrow sky window. Doing both of those things at once is a massive challenge. Okay, so that's the physics behind it. It makes sense, right? Now let's get into the really cool stuff, the material science. What exactly is in this paint that lets it do all of that? You know, painting things white to stay cool isn't new. People have done it for centuries. Even our best modern white paints, the ones with titanium dioxide, are pretty good, but they still absorb UV light, which heats them up. The real breakthrough came in 2021, when researchers at Purdue University unveiled a new formula that hit a staggering 98.1% solar reflectance. Just a whole other level. So the secret ingredient was a compound called barium sulfate. Unlike the old pigment, it's terrible at absorbing UV light, which is fantastic, because that means it reflects it away instead of turning it into heat. And here was the really ingenious part. The researchers didn't use just one size of barium sulfate particles. They threw in a whole bunch of different sizes. This chaotic mix is able to scatter the entire solar spectrum. It's a brute force approach to reflection, and man, does it work. So let's zoom out here, because this is about so much more than just a cooler roof. What happens when you start thinking about applying this technology not just to a building, but on a planetary scale? Well, the implications are absolutely enormous. The most immediate impact is right in your wallet. For a big flat-roofed building like a warehouse or a grocery store, we're talking about slashing the cooling load by as much as 70%.
For a typical home, it could be a 20% drop. These aren't just tiny efficiency gains. This is a total game changer.
But this right here is the most crucial thing to understand. Every single other cooling technology we have just moves heat from one spot on Earth to another. This is the first one that actively helps cool the entire planet by taking heat completely out of the system and yeeting it into deep space. Now, of course, it isn't a perfect silver bullet, at least not yet. There are definitely some real-world hurdles to figure out. What happens when it gets dirty? Dust and grime could mess with its reflective powers. And in colder climates, you probably don't want your house actively cooling itself in the middle of winter. And for now, to get that mind-blowing efficiency, it has to be this brilliant ultra-white, which might not be for everyone. But its most profound impact might not be in the wealthiest countries. Just imagine this paint on the roofs of schools, medical clinics, and homes in parts of the world with no reliable electricity. This is a life-saving technology that requires no power grid. All you need is a bucket and a brush. It's a remarkably low-tech solution to a high-tech problem. All of this leaves us with a really fascinating question to chew on. For more than a century, our civilization has been all about mastering our ability to trap and use energy, which has accidentally trapped a lot of heat. This technology is a total paradigm shift. It begs the question, what happens when we become just as good at getting rid of heat as we've been at creating it?